Hello viewers, so in this video we're going to look at how to determine such values without the use of calculator. Okay, so the first thing that you want to do is to draw your Cartesian plane, but you are only interested in the first quadrant on the acute angles, right? Okay, now as you do that, do a replicate of it here. Okay, do a copy of whatever that you are doing there on top. Now, this is our first quadrant here. Okay, our first quadrant, you have 90-degree angle there. Okay, you want to divide it by 2. You want to divide it by 2 so that you have 45, 45. Below 45, between 0, you have another special angle there that is 30-degree. And then that one again is 60-degree between 90 and 45. Between 90 and 45, you have 60 there. Okay. Now you are going to do the same thing here and say, okay, I'm gonna have my 45 there, my 30 there, and then I have again my 60-degree there. But now there I'll write them here as 30s, and here I'll write them in radians. On this one that we are going to use, I'm gonna write it in radians so that you get the drift. You don't fall off. Okay. So we have here 0-degree at 0-degree, and then we have 30 there, 30-degree, and then you have there 45-degree. Here you have 60-degree. Here you have 90. It's when your angle is 90. You know your point is given by x, y, right? On the Cartesian plane, your point is given by x, y. Now a point here would be 0 and something. This one will be 1. So you just follow like that: 0, 1, 2, 3, 4. Okay? And then you go this side, you put what? You put 0, 1, 2, 3, 4 again. Okay? Put 4 there. Now, those are your points. But you want to do what with these points? You want to take the square root of each and every one and put the values, the answers here that you are going to use, right? So you put the answers there like this, the points. Now, square root of 0 is 0. It goes together with square root of 4. Square root of 4 is 2. Square root of 1, 1. Same applies to all of them. Just put like that. You will end up with something like this. Square root of 3, square root of 2, square root of 2 again, square root of 3 here, square root of 1, that is 1, square root of 4, that is 2, square root of 0, 0. Okay? Now, what you have as your angle here, you have 0, and then you have pi over 6. That is your 30-degree. You have pi over 4. That is your 45-degree. Pi over 4, that is your 45-degree. You have pi over what? Pi over 3. That is your 60-degree there. Then you have pi over 2. That is your 90-degree. Now, using this sketch, you must know that your sine of an angle, theta, any angle that is special here, it is given by the value of y over r. Your r is always to the distance between these 2 points. Between this point and that point, the distance is 2. Between this point, the origin, and that point, any point that you like to choose, this distance, the hypotenuse of any triangle that you'd like to sketch here. Can you see there's a triangle here? A triangle there. So all of them, they are all here. Even the tan 90 can prove that is undefined because of this thing, because it will be something over 0. Okay? So we know that the value of r is always 2. Okay? Because of that. Now, sine, cos, let's go to cos. Cos of the angle will be x over r. Okay? And then you have the last one. Let's write it with a black pen. We have tan. Tan of an angle is given by y over x, changing y over changing x, if you like, if you want to remember it like that. We want the gradient from analytical geometry grade 12. That's how you want gradient of a line. So using using this sketch and these three things here, okay, what do you want to do? You want to solve the values of everything that you are going to solve now. Tan of an angle must be y over x. So we know that tan of pi over 4, the angle, our angle there is pi over 4. We want it to be y over x. We want it to be the value of y over x when the angle is pi over 4. You go to pi over 4 is that line. So using this point, find tan of pi over 4. What is the value of x and what is the value of y there? The value of y is square root of 2 over the square root of 2, and then you have proven that tan of square root of 2 over the square root of 2 there is just 1. Tan of pi over 4, tan of 45 degree from grade 12, you know is 1. That's how you show it's 1. Okay. Let's find our next one, that is determine the arctan of square root of 3. Arctan of square root of 3, because it's an inverse function, what you can do first is let it be the first letter of your name. Let mine, I will say r. Let r be arctan of square root of 3, right? And then I will have tan of r to be square root of 3 over 1. Remember, tan is given by what? By y over x. Where on this point do I have, where on those points do I have my y as root 3 and my x as 1? My y, remember the point is given by x and y. So I must have 1 here and root 3 there. Okay, it's this point here. It's when our uh, uh, angle r will be pi over 3. Okay, so you write r there equals to pi over 3. Remember this pi over 3, you let it be, you said is your r, okay? So you said your r is arctan, so you will say this is arctan of square root of 3. The value of arctan of square root of 3 is pi over 3. Our next one here says determine sine of arccos of 0. Now, the same applies. The inverse, we want to simplify it. Let it be r. Let r to be arccos of 0. So that cos of r will be 0. Now, when is cos of r equals to 0? What is the value of r that will make cos of r to be 0? This is 0 over 1. 0 over 1 is again that thing itself. Okay, you can write it, because now we want it to, we want it to be x over r. According to this sketch, we know our r is always 2. We can put 2 here. We can, this constant 0 divided by any constant is 0 again, so we can put 2 there and say when is our x 0 and our r 2? When our x is 0 and our r is 2, it's at 90 degree. Can you see? There we have our 0 as our x value, 0 as x value, and then you have your r as 2 there. Okay, now that's when your r is pi over 2. Okay, please make sure not to confuse the r's like I'm doing here. We have cos of r, r1, that is our angle. Please make note of that. And then we will have it to be the value of x over the hypotenuse. Our hypotenuse, let it be r2. Okay, okay, that is what I wanted to make clear. Let's continue, and I continued with all of them. Be careful with especially the cos and the sine on this video. Okay, I'll rectify it on the other videos. I will not repeat the same mistake again. Now, simplifying, answering the question that was asked, find the value of sine of arccos of 0. That will be sine, therefore, sine of arccos of 0, we let it to be r. We are looking for sine of r now. Sine of pi over 2. Remember our r we just solved here, it's pi over 2. Now, according to that sketch again, what is sine of pi over 2? There is pi over 2. The value is given by y over r. What is the value of r? The value of r on that sketch, the value of r and the value of y, the final answer for this thing will be equal to, it will be equal to what? I'll write it here next to it. So we have y, that is 2 over r. R is always 2. What is sine of 90? When you press it on your calculator now to confirm it, is 1. You will find it to be 1. The value here is 1. Using this sketch is 1. That's how you find let's do the last one, and then we continue. Before we do that, please make sure you subscribe to this channel and like, comment, and share, okay? Now let's go and look at what is the value of now. We want to determine now the value of sine of arcsine of 1 over 2. Okay, according to that sketch, let's go and determine it. Again, the inverse. We see the inverse. We want to write let r to be arcsine of 1 over 2. Okay, and then we want to say sine of r will be therefore 1 over 2, and sine is given by the y value over the r value. When is y 1 and the value is 2? The value of r is 2. The value of r is always 2. So I'm just looking for this point. Not this one, sorry. We are looking for this one. When our y is given by 1. Okay? When our y is 1 and the value of r is 2. We are looking for pi over 6. The r will be pi over 6, because that's when, and that's only when the value of sine of pi over 6 will be 1 over 2. Okay, now that we know our r is pi over 2, let's go and rewrite this as sine of this is r. Now what is sine of pi over 6? What do you get as you find the sine of pi over 6? You get, again, you go to pi over 6 again. Pi over 6, this angle, this value here. You want this line. You want to use this line here. Okay? And say the sine of that is given by y over x. Y over r, I mean. 1 over r, that will be y is given by 1 over r is 2. That will be the value. Now you have proven that sine of arcsine of something is that thing itself. Same applies to cos. Okay, same applies to tan as well. Now we are done with this video. I hope it makes sense and it will help you a lot in exams. Thank you very much. Bye.